Hello. I kind of stumbled over this topic in class, so I just want to briefly go over the reciprocal identities again. Okay, so I've set up the basic right triangle and the basic definitions of sine and cosine and tangent and cosecant. And what we're going to try to do is turn everything back into sines and cosines. So I'm just going to try to break this down in a real simple way. So to start off with, I'm going to make this r over y. And then I'm going to multiply the numerator and denominator by the same thing. Remember, you're always allowed to multiply numerators and denominators by the same thing. So what I'm going to do is put a 1 over r in the numerator and denominator, and let's see what happens. So in the numerator, I have r times 1 over r. They will cancel, and I will just have 1. And then in the denominator, I have y times 1 over r. So that will give me y over r. So you can see that here I end up with a y over r, and remember the definition of sine is y over r. So that means this thing, 1 over y over r, can become 1 over sine. Okay, I'm not going to break it down, but I encourage you to do that same trick. Multiply the top and the bottom by 1 over r, and you should be able to see that secant is the same thing. So secant is r over x, and that's the same thing as 1 over cosine. And then cotangent is x over y. So I think that's actually pretty clear to see that cotangent is the reciprocal of tangent. So this is 1 over tan theta. And now let's just go through this process of simplifying tangent. So tangent here is y over x, and I'm going to do the same trick. I'm going to put an r in the numerator and denominator. So I'm going to put a 1 over r in the numerator and denominator. So I'm going to multiply by 1 over r right there, and I'm going to multiply by 1 over r right there. And that's going to give me y over r over x over r. So this means that, remember, y over r is sine and x over r is cosine. So this means that I can actually take tangent and phrase that in terms of sine over cosine. Y over r is sine theta and x over r is cosine theta. So that's another way to view tangent. You can either view it as y over x, or you can view it as sine divided by cosine. And by the same reasoning, I can do that with cotangent, right? If I just reciprocal tangent, then I will get cosine theta over sine theta. Okay, so let me just clean this up. Okay, so here they all are, all the reciprocal identities broken down. Sine and cosine, I just like to think of them as the basic objects. And then tangent, cosecant, secant, and cotangent, I break those all down back into sines and cosines. So tangent is sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. Just something that helps me remember these is that they always switch. Okay, sine goes with 1 over cosecant. And cosine goes with 1 over regular secant. And then cotangent is the reciprocal of tangent. So, these make sense to me from doing that 1 over r trick, and then also I just kind of commit them to memory. Okay, so here is the basic Pythagorean identity that we've seen before, and I'm just going to manipulate this a little bit, and there's a few other ways that you can view this identity. For example, if I subtracted cosine from both sides of this equation, if I subtracted the cosine squared of theta from both sides of this equation, then I would get sine squared theta equals 1 minus cosine squared theta. So there's another example. You can see just by doing simple algebraic manipulation, I can produce another identity that looks different but is actually the same. So there I did it using subtraction. Obviously, if I wanted to, maybe I could move the sine to the other side and get cosine is 1 minus sine squared. Cosine squared theta is 1 minus sine squared theta. But also I could use multiplication and division. So if I start with the basic identity, this time what I'll do is I'll divide by, let's just say, cosine squared theta and see what we get. So I'm just going to take the whole equation and I'm just going to divide everything by cosine squared theta. Okay. All right, so now let's see if we can simplify this. Remember, sine over cosine was tangent, so sine squared over cosine squared is going to become tangent squared. Okay, now cosine squared divided by cosine squared, that's going to be 1. And then 1 over cosine squared, remember, secant is 1 over cosine, so this will become secant squared theta. So there's a lot of ways that you can take this and use addition or subtraction and algebra to kind of push these symbols around and take basic identities like this one and turn them into things that look different but really are the same thing, like this one here or that one there. Okay, here is the first question on the homework. We're asked to simplify this, 1 over the square root of 1 minus cosine squared. So my hint for this problem is to start with the basic Pythagorean identity, and then I'm trying to have something that looks like 1 minus cosine. So the hint here, I'm trying to have something that looks like 1 minus the cosine squared of theta. So the hint here is to start with the basic Pythagorean identity and then subtract cosine squared theta from both sides. Okay, for B and C, the hint is both of these are just fractions that have secants and cosecants in them. So the hint is to use the reciprocal identities. To turn into sines and cosine. Turn everything into the sine of theta and the cosine of theta, and then some things should cancel out and it should be able to simplify. Okay, I'm going to do a problem that's similar to 2a. I just changed everything into its like co-version. So here I'm going to just try to simplify cotangent plus cosecant. So the way I'm going to do that is cotangent is cosine over sine. So just like as a general strategy, I always try to turn things back into just sines and cosines. And then cosecant is 1 over sine theta. So that means that this thing can simplify. Now that these things have a common denominator, I can make this cosine theta plus 1 all over sine theta. And I don't think it can simplify further than that. Okay, so now I just want to give you a little hint for 2c. We're asked to use least common denominators to simplify this expression. I got 1 over sine squared plus 1 over cosine squared. So sine squared and cosine squared, they don't have any common factors. So the LCD is just sine squared theta times cosine squared theta. So now I'm going to look at this one. Okay, so his denominator is missing a cosine squared. So that means that I have to multiply the top and bottom by cosine squared theta. And then over here, when I look at this one, he is missing a sine squared theta. So I need to put a sine squared theta on top and bottom for this one. Okay, so you're almost done here. Now that they have a common denominator, you can just simplify this and see what you get. Something interesting should happen in the numerator there. Okay, so I just want to give you some hints here for problem 4. The first thing is this: cosine theta times tangent theta equals sine theta. So my trick for that is to just turn this tangent into sines and cosines. For part B, do the same thing and then use reciprocals. Okay, for part C, my hint is to foil the cosine theta plus sine theta squared part. So just FOIL this thing out, and then you should be able to use the Pythagorean. The Pythagorean identity. And then for part D here, you need to just turn into sine and cosine. Actually, this one, cosecant, you're just going to turn this basically into sine. Wait. Yeah. And then distribute this. I was just panicking when I was looking at this. I was trying to do it in my head. For a second there, I thought it was wrong, but when I look at it now, I think that it's right. So, I understand that these are like kind of unpopular questions for students. It feels kind of pointless to just push the symbols around on a page, But if you just get your mind in the right place, hopefully you can find a way to try to make it fun and just think of it like a puzzle. And I'm here to help you. Please, sooner is better than later. Reach out to me if you get stuck and let me know if you're having any problems. See you guys on Wednesday.